feel like I do better when I study on myself.
What?
I feel like I'm more productive when I study on myself.
Yeah.
Check over here.
Okay, questions? If you have problems with the homework, now we can go over them. I know that we did not before the problems, solutions, so yes.
I don't have a specific question. I just wondering, like, when you're starting out on a problem, what are you looking for to know, like, where you need to do your KVLs and your KCLs, and so you're not just like randomly doing
Getting
them all
lost,
over the place?
that's
Yeah.
right. Well, given a circuit, right? There's a number of KVL equations and KCL equations you can write. Okay. The important thing is, because eventually, even if you're going crazy and writing all those KVL, KCL equations, you will get to the solution. But the problem is, you're going to keep writing the same equations, which we call the dependent equations. Okay? So, like with the KVL loops, it's not that difficult to see. If you have two loops, right? Kind of like adjacent to each other. If you're writing a KVL on this one and then not a KVL on the other one, then the outer loop will be a dependent equation. Which means that you could write that equation by using the equations that you already wrote.
Okay.
Okay? That's what a dependent equation is.
Okay.
So in order to avoid that, like for KVL, you can identify the loops, not like getting in each other, but like the independent loops. That's going to give you more or less roughly how many KVL equations you can write, independent equations. So if you already wrote an equation, like that, okay? Well, even let's kind of like finish that. So here when you look, you said there are four independent equations, four independent loops that are not interlocking each other, okay? Now, if you wrote this one and that one, writing this one will be unnecessary.
Just a waste of time.
It's not more than a waste of time, actually. If you're taking this, counting this as a equation, if you plug it in to calculator to solve for three unknowns, let's say 1, 2, 3 equation, the calculator won't solve it.
Okay.
Because the red one is not a new equation. Okay, by only adding those two equations that I wrote, I could get that anyway. I knew that information. It's not new to me. So you have to avoid those things. The way to avoid those is seeing those independent loops that are not kind of like getting into each other. Okay, like you said you wrote this one, for instance, okay? And then you wrote a KVL, let's say here. Now, going through this one, again, unnecessary. Okay? So, when you look at a circuit, you have to always remind yourself you have only KVL and KCL. And there's also Ohm's law. But in terms of looking at the loops and then the nodes, you have KVL and KCL. This problem has to be solved through those two loops. Okay? So, looking at the KVL options, what are your options? You go through those. Then thinking about your KCL options, which element? If you have something like that, right? There's no point in defining this point and that point and then applying a KCL at that point. That's not an essential node, right? An essential node is where you have at least three components joining together. So then you think about the KCL nodes, but at some point, let's say, let's complete this one. Now, if you have currents over here, okay, so let's say I1, I2, I3, okay? Now, let's say you already wrote the KCL here, because that's I1 coming, I2 coming, I3 leaving. Now, if you try to write another KCL like this, no, again, that's dependent, right? Same equation. So looking at that circuit, even though there are multiple options, you know that out of this circuit, you can get only 2 KVL equations, independent, and 1 KCL equation, and that's it. Okay? So there's no point trying to write a KCL at every node that you see, every loop that's possible in the circuit when you have 4 or 5 loops. The number of loops are too many, right? You can go anywhere because 1, 2, 3, 4, 5, 6. So it's getting out of control quickly. So you have to kind of like, the trick is to kind of be able to identify the dependent equation so you don't keep writing the same equation. But unfortunately, there's not like a set recipe to kind of like follow. But the important thing is generally the point where you keep writing and writing and writing, but you can't get to the solution is because actually you keep writing the same equation. Okay? Yes.
These are like you wrote 2 independent KVL, right? First 2, right? And then 1, 2, and then you chose another loop, including the third one, right?
Yes.
Yeah. So that is acceptable, right? 1, 2, and
If you choose this one, and then that one?
yeah,
Yes.
that's
Then-
acceptable because you have one thing unknown. Joined
Yeah,
there.
see, I mean, the thing is, if this is R1, let's say, and this is I1, okay? When you are writing this loop 1 for your KVL, you're gonna have da 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 da, and then when you're going through here, you're gonna have plus I1 R1,
Right.
and then da 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 da, right? When you're writing this one, KVL2, you're gonna have all those things, and when you're passing through here, now you're gonna have negative I1 R1, right? So if you actually add those 2 KVL equations, the things on this line, on the border line, will cancel each other. All you're going to be left with is going to be all those outer items, which is like as if you're writing the KVL here. So it's same equation.
And then the third loop is the
But
other
if
loop.
you're here, yeah, that's an independent equation.
No, like including 2 and the new third one.
This?
Yeah,
yes,
this-
that's an independent one.
Okay, that's independent.
That's
Okay.
still independent because now you're taking into account this information. Yes.
So on the exam questions that you emailed out to us, the exam to review questions, a lot of them through the work said they use CDR and VDR, which we haven't gotten to yet.
No, but it's, so here is one from, that we probably looked into that. So let's say this is R1, R2, I1, I2, okay? Normally, you can get I1 being equal to R2 over R1 plus R2 times 4.7 milliamp. This is CDR, okay? But you don't know this. Now,
But you can
what
use
do
it-
I do?
You can use it if you know it, right?
If you know what you can use, but we, believe it or not, we generally have more mistakes with this than the usual way. Even after I go through the VDR and CDR, I always tell in the class that if you are not sure about it, don't use it. Okay? The sign errors and all that, we have a lot. So, but let's say you don't know that. You have 2 unknowns over here, right? I1 and I2, that's what you're trying to solve for. Now, I know that KCL at that point tells me that those 2 currents add up to, because KCL is giving you the currents through parallel components when you know the total current going through them. So my unknowns are I1 and I2. So one equation comes from the fact that I1 plus I2 is equal to 4.7 million, right? And another equation, I can write the KVL here. So I1 times R1 minus I2 times R2 is equal to 0. And that's it. Actually, you arrange those equations, 2 equations, that's where it comes from.
Okay, so are you saying
This
that
is
you would
not
just plug
like-
the equations into each other then, and then you'd be able to rearrange?
What I'm saying is like CDR is making those 2 equations into 1 equation. So instead of writing 1 equation, you are writing 2 equations. But believe it or not, to write those equations correct is much more possible than getting this equation correct.
Because you can like derive it yourself as opposed to just trying
Exactly.
to find the right equation.
Because most of the time, people are memorizing what sign there should be over here. But it's actually, if you can see that, that's nothing new, but it's coming from this one KCL, one KVL equation, you will get the sign always right. But what I mean is, it's not using CVR, it's not gonna cost you anything. As long as in a specific question it says use CVR. And that's not gonna happen in that example.
Because I was doing I think the first question on the review, and at one point you have like two resistors in parallel, and you're looking for the currents across them, you know, both their resistance, and like in their work they put it in CDR form, like I didn't know how to get that.
In the solution, depending on, see, you have to always now keep in mind that when those problems, exam problems were posted there, they were from 2300, right?
So
Now by exam 1, we were doing NBM. We were done with NBM. So CDR, VDR, those device modeling problems, series, parallel combination, everything was done. So at that point, when it comes to the solution, we are putting the shortest possible answer with what you know. But it's not like, it's not doable if you don't know that. So you can still work on those things. There are so many things now. Now you can also say R1 and R2 in parallel, right? So you can say the voltage here, let's say V1. V1 is equal to R1 in R1 times I1, right? That's the voltage. And then you can also say that when you combine them in parallel, V1 is equal to parallel combination of R1 and R2 times 4.7 milliamps, right? Because 4.7 milliamps is the current flowing through the parallel combination, which is again going to create this voltage drop, V1. But V1 also equal to R1 times I1. Again, solve those, that's this.
Because my hardest thing was like, looking at this, I figured I could put it in parallel, but I didn't know what happened to the currents that were attached to the resistances.
Yeah, so you lose this current.
Yeah.
That's why, but you have to be careful, you can get around that. So you know that voltage can be written as R1 times I1. Also, it could be written as R2 times I2. That's also what that KVL tells, right?
Yeah.
I1 R1 is equal to I2 R2. Right? And then also you know that those currents are adding up to this current. So it's the same logic. That's actually how we're going to prove, how we're going to come up with the CVR formula. Okay? So it's not really like saving you tons of time, because instead of one equation, you're having two equations.
I get the R1 parallel R2 times that main current going in. That makes a lot more sense.
And then that gives you the voltage, right?
Yeah.
And then voltage divided by resistance will give you individual. If you divide it by this resistance, you will get this current. If you divide it by R2, you will get this resistance, this current. Okay? So it is just giving you a little bit of one equation missing, but writing this equation correct is more difficult than writing those equations correct. Yes.
I have actually this problem. So
Okay.
as we went over through like looking at the independent loops, like to simplify how many loops you can write. So while I was solving out, I don't know, but I came up with like more than 5 unknown variables.
Okay.
And to find out like, okay, now I have 5 unknown variables, so it means I need at least 5 equations, right?
Yes. Correct.
But I don't know, I just got a wrong answer for some reason, and when I look at the solution, they did it with like MCM and the node voltage, so I don't know.
We don't have those right now, right? So the first one is that it depends.
Yeah, the 2 circled one, actually we're looking for power on those sources. question is, what's the power delivered by IS1 and
Okay.
VS2?
Okay, so let's see what we're looking for, okay? Power delivered by IS1, so let's label this one. And then power delivered by VS2, which is this one, right? That's what we're solving for. Okay? So let's start writing the equations. Now, without writing anything, and I'll likely write a KVL if I'm looking for V1, right? That's what I'm looking for. I'm gonna start by writing a KVL, kind of like having V1 in the equation, okay? So I'm gonna go through this KVL over here. But in general, by just looking at the circuit based on what we discussed, how many independent KVL equations can I get out of this? Three equations, right? 1, 2, 3 loops. I have 3 loops here, right? So then let's start with this one. So what I have is V1 plus. Now, do I know the current through this resistor?
I think that's IS1.
IS1, right? IS1 determines the current through this branch. So I have plus 200 millisiemens Vx times 110 ohm. Then, how about this current here? Do I know that? The current through 470?
No.
I don't, so then label it I1. So I have plus I1 times 470, and then plus Vx, probably I'll need to label that current eventually, equals 0, correct? For components. Now let's look at our unknowns. So I have V1, I have Vx, and then I have I1. If I don't introduce any other new variables, at least I need 2 more equations here still, right, to solve for the unknowns. So let's keep going. Here is the one. So I have V1 over here. So V1 is gone, right? Vx, I1. So that's 2. So this is KVL1. And this is KVL2. So I have negative I1, 470 ohm, plus 25 volts, plus current here, you don't know yet, right? Do we?
No, we don't.
That minus I1.
Which one?
IS1 minus I1.
Yeah, but we will do it as KCL, okay? Yeah, you're right. It's IS1 minus I1, right?
Yes.
But let's just label this first. What do I have? I1, I2, let's make this I3. So then I have I3 times 220 ohms. And then what here? Current here? You don't know, right? Label it. I4 plus I4 800 ohms equals 0. Now, what did I introduce? I did I3 and then I4, right? So we can, so what he says, let's do an KCL over here. We can do that. So that actually makes I3 known because we have negative IS1 plus I1 plus I3 equals 0. That's good. Put IS1. I want to say negative 200 milliliters. Yes. Okay. Plus. Can you read that? Okay. So I didn't add anything here, right? I1, I3, Vx already in my list. So keep going. So then, what else I can do?
KCL on the right side.
KCL over here.
Right there.
Okay, so then that's V. So if you write a KCL at V, that's negative I3 let's start with this one. Plus I2 plus I4 minus I3.
Now, don't we need to add I2 to our unknowns?
Say again?
We need to add I2 to our unknowns?
Yes. So how many? Now keep, so the trick is, we're going to keep writing those equations, we're going to keep track of the unknowns, okay? So 1, 2, 3, 4 equations so far we have, right? So we have 1, 2, 3, 4, 5, 6 unknowns we have. So we need two equations to go. So what else we didn't use? We didn't use this KVL, right? Let's use this one too. We know that that's new. So we have negative Vx minus I4 800 ohms plus I2 250 minus 12 equals 0. That's it, right? 1, 2, 3, 4, 1, 2, 3, 4. So what else now? Vx, I4 is already in the list, I2 is already in the list, so I'm good. Didn't introduce anything new. Yeah.
What if you do the KCL in the middle node? Is that
Which one?
the middle node? I1, I4, and VS.
Over here?
Yeah.
You can do that.
You would
But-
do the current
Well, okay, so this is C, right? So if you write a KCL at C, you have negative I1, negative I4, 1 and 4 are already in my list, right? And can I write this current in terms of something in my list?
I1 plus I4?
I can, right? So that's Vx over 1000 is the current leaving the node. So plus Vx over 1000 equals 0. Let's see. I1, I4, Vx. Now, equation 1. So 1 here, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
So for C that you just wrote, if Vx's sign notation was flipped, so it was minus on the right, plus on the left, then would it be negative Vx over 1000?
Yes. Because it's obeying the Ohm's law in passive sign convention, right? So whichever side is plus, the current is flowing from higher potential to lower potential. Okay?
Do you still need KCL B to C?
Do I still need what?
KCL B to C.
So this one and that one are not dependent, right? That's still a new, this is, so the question is, where are your KCL equations? So this one, that one, right? So can you get this out of those two equations?
No.
You can. So that's not a dependent equation. But if you write 1 here, that's dependent. Now using those 3 equations, I can get this one because check that. What I have here is 200 millisiemens Vx, and this is now coming to the node, right? So negative Vx over 1000 ohm minus I2 equals 0, right? Look at that. Let's see. So if you actually add them all together, right? I1s cancel, I4s cancel, I3s cancel. So negative, this is the negative of this whole equation. Negative this plus I2 plus this equals 0. That's exactly the negative of that equation. Do you see that?
Yes.
If you add, this can be obtained. This is negative of equations 3 plus 4 plus 6. If I add those 3 equations, negate them, I get this one. So I know that's not new. Instead of writing this equation at this node, if you write the KCL at this node, then that would be okay. It wouldn't be independent, dependent equation.
Pretty much
Okay.
as long as you don't like have, if you have 4 possible KCLs, as long as you don't have all 4, it's okay.
Exactly, yes. So I mean, in that case, you have 1, 2, 3, 4 essential nodes, right? Out of those 4 essential nodes, you can use any 3, but the 4th one will be a dependent equation.
The same with KVL, like you use.
Yeah,
3.
because it makes sense, right? This current is coming, then splitting, then there's this one joining, then coming, splitting, and then turning back. So it's like a loop. So eventually, splitting, combining, it goes back.
Goes to 0.
It's like exactly the way that we discussed. It's like easier to, I give this example because it's easier to see, but it's exactly like that, right? Those currents coming in here are actually leaving this node. So this one and that one are, one of them is in the dependent equation, same here. So the the idea is not to get lost. You're looking at what you're asked, right? And eventually when you actually solve for those things, then the rest is actually, can be solved for easily, because this one is wants V1, that one wants I2. Look at your unknownness. When you solve those simultaneous set of equations, you're gonna get them all. Okay, the rest is just to put them into the power equations. Now, suggestions, I mentioned that also in classroom too, but the main points are on those equations. Say that's like a 35-point problem in the test, right? So how many equations we have? 6. So my grading would be like around 4 or 5 points each of those equations, right? And then 2 points on this calculated, 2 points on this one calculated, something like that. The actual numbers, why I'm saying that, if you are not familiar with your calculator, or if you are spending more time than required, I always suggest write down the equations, leave the calculation part to the very end of the exam. Finish the exam first, then come back, because in this other question, if you are wasting your time to solve this, and then you are missing 2 questions from the next one, missing 2 equations from the next question, that were 8 points, the final result of the previous question is 2 points. Okay? So don't spend crazy time on the calculator. That's not what we are grading.
By hand, like I know some people have the TI Inspires where you can just plug the equations in. Like I have a TI 83, so like I would have to go through
Matrix, I know, that's why I'm mentioning that, because depending on what you are using, or also depending on how familiar you are with it, okay? Maybe you might have both one new two. Depending on that, this part can take quite some time. What I'm saying is don't spend that much time. I had like the first time I was teaching this course, I had one student who didn't use a calculator at all throughout like all the midterms and final exams, and she managed to get an A because every equation, every single equation she put on the exam was correct. So it's possible, okay? The emphasis is on writing those things with the signs and all that correctly, okay? Yes.
Okay. It's kind of a stupid question, but I
No,
still
go
can
ahead.
ask.
No stupid question.
So, 6 equation, and you just specify V1 in this one equation. That's fine, right?
What?
Okay. There are 6 equations, right? 6 unknown variables. But the V1 we just use in first equation. That's okay, right? We don't have to use the one variable at least twice in like 2 different equations. The V1.
Not exactly sure.
Okay.
So
We
this
have
is
six,
one equation, right?
we have 6 unknown variables, right? And we
But
wrote,
this 6 unknown variable, we didn't came up with that like that, right?
Yeah.
We wrote this first equation because we were trying to solve for V1, and when we were trying to solve for V1, we wrote an equation, but then a couple of variables came. In order to write other equations for those ones, then other variables are introduced, right? So along the way, then I came up with this six unknowns.
right. So V1 doesn't have to have like in some other equations also, right? It can be on the
No.
one equation, right?
There's no rule like that has to be in that equation twice or 3 times. All I'm looking at, all I know is KVL and KCL, and all I'm trying to do is I'm trying to avoid the dependent equations. That's the only part that's tricky. Okay? Because you all know how to write KVL, KCL equations. You don't have any problem with that. But the part is you write equations most of the time more than required, right? You then plug them into the calculator and it ends up calculator doesn't solve it. It's because you have more than enough equations but not an independent set of equations. Okay?
So as long as we use each variable once, it doesn't matter if it shows up 3 times in the 6
No,
equations.
No, it doesn't matter at all.
Yeah.
It doesn't matter.
And it'd be one fewer equation than we have possible that is not dependent. Did I phrase that right? Because you said there are 4 possible KVLs in this, but only
Now,
3 of them are
these are a
independent.
set of 6 dependent equations, right?
Yeah.
Let's look at the options. Now, on top of everything I wrote, let's say I'm writing another KVL going through this loop. That's a dependent equation.
Yeah.
Let's say I'm writing this KVL. That's a dependent equation. Let's say I write a KCL at this node. That's a dependent equation. Meaning, all those equations can readily be obtained from those equations with algebraic manipulation. like this example that I gave you. Okay, that's the point.
But you said if there were 4 nodes, we can use 3 KCLs.
But I mean, this is like in this circuit, yes, those are not rules, right?
Oh, okay.
Those are not rules, depending on, because the circuit is kind of like connected back, right? Completed. There are circuits with not completed paths, right? Broken circuits and all that. So it depends on the circuit. But in that circuit, there are 4 essential nodes. There are 4 main nodes you can write in KCL. And if you write all 4, one of them will be a dependent equation. That's what I'm saying. Okay? Any questions on this one? Yes.
So you can always write n minus 1 equations and given the number of nodes that you have?
Well,
No.
you can formalize it like that, right? That's we're gonna formalize it in MCM, but it's not like that. So it depends on, definitely it's depending on the number of nodes. That's one thing, but it's not that only. There are also variables introduced through dependent sources, right? So with them, you can actually, by looking at that, you can kind of figure out how many equations you're gonna need, depending on if you're applying NVM and MCM. But you're not gonna be using NVM and MCM in this test.
You just have to make sure that like the equation you're writing isn't dependent because you've already established like the loops inside of it in another equation.
Yeah, so my suggestion, if you are looking at that circuit, and then, well, okay, I see a loop, that's a KVL, then you write this, then you write this, but if you go like that, if you don't do it systematically, you will eventually get lost. You won't be able to get, keep track of your unknowns, you won't be able to keep track of your independent loops. Go in order, like with the KVL loops, one way is to, and then kind of like when you're writing, label your equations. Just not for us, for yourself. Make sure that, is it a KVL equation, KCL equation? A KVL equation and a KCL equation cannot be dependent, right? KVL and KCL gives you, so let's say, like for instance, you ask me, is this gonna be a dependent equation? What did I look at? I look at the other KCL equations. I didn't look at the KVL equations. If you write them without knowing which one is KCL, KVL, you won't be able to take a look at it. So I look at this, I look at that. Can I get this out of those 2? I can't. Then it's an independent equation. Okay? So make sure everything is organized. That's going to help you as much as it will help us. Okay? Any questions? Anything from the homework? The last homework problems were good problems. That's okay.
Definitely depending on the cooking. Horrible.
I think that's homework problem 3. Vx. Okay, so what is the best way to start this? We're gonna write the KVL, kind of going through Vx, right? To get Vx included in our equation. But before that, because when I'm writing KVL, I'm gonna start labeling currents and all that, right? In order not to label currents that are more than required,
Find
so
the dummy
let's
resistors.
first look at the circuit for a minute, doing nothing. Okay? Nothing. Don't write any equations, don't start writing down the equations, but look at the circuit. What do you see?
The 7 ohm resistor is a dummy
The
resistor.
7 ohm resistor, any current on that? There's no, right? If you take a closed surface here, the closed surface tells you that there's only one branch leaving that closed surface, so that current has to be 0, right? Also, any current through 15 ohm resistor, that's open circuit, right? So this is also 0. Right? Okay. So what else? There's no current over here, right? But it doesn't matter. It's mostly important for the resistors, right? So I'm good. Let's get started. So I want Vx. So I'm gonna go through, I'm gonna write an equation involving Vx in it. And then that's like a KVL equation, okay? So let's start from this note. I know that I want to include Vx, but then we will figure out how to go. So Vx, this is 0. I'll go through this for sure. Negative 10 Vx, right? At that point, where do I want to go through?
Through VS3.
There's like a shortcut here, right? Nothing. So go through here, then negative 5 ohm Ix. Coming over here. You can go anywhere. You can either go through this or this, but there's a voltage source here, right? So 6 ohm IQ. Nothing here, no voltage. And then there's already current
Plus
defined here, right?
IQ
So
times
I'm going to go to plus 9 ohm IQ. 0, right? Now, I got my Vx. What else did I get? Vx, Ix, IQ. At least 2 more equations I'm looking into, right? So now what can I do? So I used actually Vx, right? So concentrate on those variables that you want to use in your equation, because ideally you want to be able to write 2 other equations only using those variables. So then I have to look into the circuit and then trying to figure out where those variables are, okay? So Ix is here. Let's start with Ix. Can I write something Ix in terms of IQ?
yes. No, you can do KVL because the voltage is
KVL,
parallel.
I mean, you can write a KVL over here, or you can say that this is a voltage across this
Yeah.
resistor. You can use it like an Ohm's law, but let's call this loop 2. So this is my KVL at 1. Then this is my KVL for loop 2. So I have 6 ohm IQ plus 11 ohm Ix equals 0. Perfect, because both IQ and Ix in my list. Now I'm missing one equation only. Now let's concentrate on IQ this time. IQ is here. It doesn't look like I can write something for IQ. Can I?
You can write a case.
Correct.
We are not doing it right now, right? So let's write a KCL at that point, right? Because I'm interested in writing an equation for IQ, and IQ, that's a current variable. So I'm gonna try to write a KCL. So if you write a KCL, say at that node, KCL at A, what does this give me? Negative 4 amps minus IQ, and then let's come up with a current here, plus IQ equals 0. That's okay, but I introduced a new variable, right? I3. Now I have to look for another equation. Concentrate on I3 now, because that's a new variable that we introduced, right? I3 is here. I get a KCL out of this. I can get
A KVL.
out of it, right? Only by using those 2 variables. So if you do this KVL3, so I have 9 ohm times IQ plus 13 ohm I3 equals 0, and I'm done. 1, 2, 3, 4 equations for unknowns. This one? So what we went through was, we started here, we took this shortcut, and I went through the voltage source, and then this one here.
So we skipped over the 11 one because it's better to have the voltage source.
Because I already know that, right? KVL is adding up voltages. If I have a voltage source, you could just do negative 11 ohm IX as well.
Okay, yeah, see that, that's where, okay.
Doesn't matter.
But those voltages are equal, right? So it's the same
Eventually you are writing this, right?
thing. Right, yeah.
So it doesn't matter. Okay?
So the key thing is, do not avoid to write a KVL for dependent or independent current source, if we can, right?
When you're writing a KVL equation, of course you like the voltage sources,
Voltage source,
dependent
okay.
or independent.
But when you have
you're
to,
writing
you have to.
KCL, you want the current, right?
Right.
So now I'm gonna add up the voltage from this node to this node. A current source is a mystery, right? Don't know what the voltage is. I can go through the 13, eventually I labeled that, but at that point I didn't have that, right? So I see IQ is already defined, then I'm going through the variable that's already defined. Yes.
Is it better to always write out the whole system of equations like this? Because like in this case, there's pieces of this that you could do by themselves, and then you would have fewer equations. You know what I mean? Like you could solve for IQ by itself before doing any of that other stuff, and then you've got.
Generally, you're looking into what, like you see over here. That was actually short, right? The previous question, like you're looking into 6, 7, 8 equations, right? If you try to solve for something, then use it somewhere else, substitute and all that, you will be lost.
Okay.
You won't be able to solve like that with the hand calculations.
Okay.
So it's better to come up with the, and plus we are not giving much points to the solution anyways.
Okay.
You're not gonna get any extra points if you have IQ over here calculated in the middle of those equations or not.
Okay.
Okay? So it's much better because this way you can actually, it's nice to kind of like get them all like that. It kind of gives you a better idea of if something is depending on something, right? It gives you a better idea of how many variables you have. So that if your equations are enough, right? All those things. So that's better.
Okay.
Okay?
Right.
Like if you look over this question now, if you kind of didn't read the question, okay? Let's say you don't know that you're looking for Vx, then actually if you look at the loops and all that, right? You could define the current here, right? You could well, there's not much you can do over here, but I guess this one. So what my point is, read the questions. Sometimes there are more equations you can write out of the circuit, but to solve the variable that is asked, you don't need all of them. Okay? So especially that's true for, we don't have that many dependent sources here. Especially it is true for dependent sources or sources in general. You have a voltage source, right? Or let's say current source. So let's say you have a current source in that equation here, okay? Now, when you are defining the voltage across this current source and when you are actually taking this into your unknown list, you have to ask yourself, do I need this voltage? If I don't necessarily need that voltage, because defining this voltage across this current source will definitely introduce an extra variable, which means an extra equation, okay? If you don't need that, if the question has nothing to do with that variable, don't define it, and don't write this KVL going through this current source, okay? Even though it's an independent equation, it will be an independent equation, and you will solve for that voltage, but you don't need, if you don't need, why write it, right? Yes?
Would it be bad to, for this particular question, to make those resistors in parallel on the top left corner?
On this top, the 9 ohm and 13 ohm, if you connect them in parallel, and if you don't keep track of IQ, IQ will be lost, right?
Yeah.
IQ is the current through 9 ohm resistor, not the parallel combination, because when you combine them, the current that's gonna be flowing through the parallel combination will be this current. There's no way that you can recover IQ then.
Or I3.
But you can do some tricks, right?
We can do
You can
voltage
calculate,
dividing.
you can calculate the voltage. You can say that this voltage is IQ times 9 ohm, right? So plus minus, if this is that voltage, you can say that this current over here will be voltage divided by current in passive sign convention. It's going to be IQ times 9 ohm over 13 ohm. Right? You can use such tricks and then, but you don't really need that. It's still, you're writing an extra equation which is actually included there, right?
So how did you divide by 13 ohm right there? You just wrote down? When you were showing that you could create a voltage out of that.
Which one? This is, so you know that this current flowing through 9 ohm is going to create a voltage with positive minus polarity equal to the value I times R, right? So that's this voltage across those two terminals. But those two terminals happens to be the same terminals for 13 ohm also. So this is also the voltage across 13 ohm. So then from voltage I can go to current by V is equal to I times R, right? So then I here is equal to this voltage divided by resistance.
So that new I, like I 13 or whatever, is equal
So,
to that.
I mean, as a result, this current is not a new variable, you're writing in terms of IQ, which is the same thing that you are doing here.
That was one of the questions that I had too, because like I haven't really done that. Like, how do you conserve the current when you do resistors in parallel, and like it's just like something that
I mean, it's as long as with those things like combining, simplifying, and all that, those are kind of like to make the circuit a little simple, okay? But while making the circuit simple, if you are making an error, that's worse, okay? So whenever you are not comfortable, until you are not comfortable with that, you shouldn't use that. You shouldn't do those simplifications, okay? Yes?
Do you have the right model on this?
No, no. Homework 1 through homework 4 material. Device modeling problems are in homework number 5. Okay?
Is the current to VS3 zero?
Current to VS3? Yes. Because if you actually do like a closed surface like that, right? Nothing coming in, the only branch is this one, right? So the current here will be 0.
So can you figure out IX from this?
Can you figure out IX with IX? Well, actually, IX is an unknown list, right? So when you solve for those 4 equations, you will get all those variables.
Because it's 5 IX, 5 minus.
Okay? But that's voltage. That's voltage, right? So there is a voltage here, but the current through is 0. Okay? Questions on that? Yes.
Just like, is it possible that we have a question with the current dependent on time? Like
Current depending on?
the time, like it was one.
Everything is possible. Yeah, but I mean, like the power ones, right? Where you did, it was more possible in the first exam, right?
No, wait. No, not power. I'm talking about.
I know.
Yeah, like
but
the one on the PowerPoint, right? where we
Example.
Oh, the
have
PowerPoint,
like
yeah.
the integral. Well,
It's-
it's on the PowerPoint. you
like
might-
in those problems, it's hard, like given a circuit, now IX is changing with time and all
Yeah,
that. It makes those things much more complicated. But when you are only doing power calculations, energy calculations, that makes much more sense there. Which is included in the test.
I don't know, I think she was trying to say that it won't. That's
How
what
to
it
plug
looked
it into the
like.
calculator?
She was trying to say that it won't. That's what it looked like.
I can help you with that, I don't know. It's, I think, probably inspired, I mean, ask someone who's using the calculators, I'm putting it into the Wolfram model and then it solves it perfectly fine. But, it's. If, isn't it gonna work if you write just the regular equations?
Yeah, if they're dependent, it's not gonna work.
I think it's, there's,
I
you
learned
can
that the
kind
hard
of,
way.
I think we can maybe define 1 over R like a variable. Is it the problem that was 1 over, I know some people were discussing this. If you kind of like define something like that, X, and then make it like a variable, and then solve for that, and then from X you go to R. But the calculator issues, I don't know.
What calculator?
That's the 80.
I think in Inspire you can, do
Yeah,
that.
Inspire
But
is
it's
really
maybe-
easy.
No, not even on that. 'Cause it's
Really?
just- INR is like the defense, and there's no number for them.
But you don't need that. The important thing is there are 4 equations there, and then there are 4 unknowns. Right? And you plug those equations into MATLAB, you plug those equations into Wolfram Alpha, it gives you those 4 unknown values. So perfectly fine. It's just I don't know how to enter it in the calculator. What else?
What do you mean schedule?
Yes.
Oh, is that why? Because I gotta eat next week.
Okay, that's no problem.
Maybe they're gonna eat this good.
Probably. I mean, they sent emails out as soon as like you're
I'm trying to like,
You're trying
to do like,
trying to plan it out.
plan it out.
I might
My business degree.
honestly, bro. After I should take like circuits to the summer just to get done with it. That's what I want to do, man. And tech con.
Yeah, for sure.
Tech con and circuits to
And
the
programming applications too. Like, honestly,
Damn, you don't want to have fun during the summer,
Well,
do
but
you?
it's the thing, it's all in the first session. So it's literally like a month and a week of like 5 months of just like
Hell.
hell. And then I can enjoy the rest of the summer. And I'll be caught up. You know what I'm saying?
Yeah.
It all makes sense to me. But then I try to do it. Like, take too long.
Oh, this question. This fucking question. Exam 1, spring 2009.
You recognize this?
Huh?
You recognize this?
Yeah. It's one of our
And you
questions.
got all these guys memorized?
Yeah. I mean, when you stare at it for like 5 hours, you have it memorized by heart.
Julie, you're not trying to say.
People actually do that, but they're in their own field. When I went to school, like, you just memorize it.
Just memorize the circuits.
What I did was put the bottom two in the series. That one on top.
This is a bad assumption.
Never assume that.
That's what I'm saying. I don't want to be
Dangerous assumption.
I feel like they just got that serious.
At least you're a positive person.
Okay, so we're solving for VQ, VX, power delivered by
Maybe
4.7
that's it.
million,
You're like, you
right?
don't know her shit. She's like, gotta change these if they're not ready.
Okay, let's start with trying to find VQ, okay? So, what do I do?
Using KVL and that.
I'm
Oh,
gonna start
find your
with
dummy
VQ,
resistor?
KVL, and then I'll
Oh.
have VQ in it, right?
Okay.
So that's gonna be my
Find your
solution,
dummy
but-
resistors first.
What?
Find your dummy resistors.
Yeah, let's first see, so in order to write an equation, KVL equation, I'm gonna need to define my current here, right? I1. But before getting crazy and labeling all the currents, let's look at the circuit for a minute, okay? And then see what we can see here. Now,
3.9 kilo ohms.
there's always whenever you have this gap, whenever the circuit is not completed, be suspicious about that, right? There is a zero current there, and see if it gives you anything, if it lets you do anything simpler. So this current is 0. That means this current is 0 over here, right? If this current is 0, there's no point in finding a current here and current here that is different, right? Because this I1 will come at that junction and it will flow downwards. So I don't need to define this as a new variable, but that's just plain I1, right? Now over here, also this current is 0. Okay, so if you're looking at that current through a 6.8 kilo ohm not sure if I'm gonna need that or not yet, okay? If the question, one of the questions was asking, what is the power absorbed by 7-volt voltage source, I would need that current, right? But right now, I might not need it, I might not use it at all, okay? But just label, put your 0 amp over here so that just to remind you that this current and that current are the same. Now, because I want to label only the things that I'm gonna need, okay? So I'm starting with my KVL on that loop here, 1.
No.
So I have KVL 1, negative 12. Then I have, now look at that here. I1 times this, I1 times this.
Oh, no,
Well,
I think it
actually,
is.
let's make this separate in 2 steps. 1.7 kilo ohm times I1, because I want to include VQ. Negative VQ plus I1 times 3.3 kilo ohm plus 6.3 kilo ohm IQ equals 0, right? So, now let's see what I have. I1, VQ, IQ, right? Now, I can easily write I1 in terms of VQ, right? Ohm's law. So let's get this out of the way. Careful, current flowing, active sign convention here. So VQ is equal to minus I1 times 2.2 kilo, right? So I get my second equation without introducing anything new. I'm still missing one equation. So I kind of like both my equations involving I1. I got VQ involved. IQ. Where's IQ? IQ is way at the bottom, right? So let's now concentrate on IQ. This is what we discussed, right? The beginning of the session here. So over here, I won't be able to, for IQ, if I want to write a KVL, I still need to define some variables, because let's say you want to write a KVL, okay? So IQ times this, then you're going to try to go through here or here. Now, here means defining this voltage. If you go here, defining this current, okay?